Hi everyone, and welcome to the Scala Barcelona meetup. I see a lot of new faces here, so before the main presentation, I'm going to just give you a really brief presentation about what we do. Right? So some important things. So here you have the link to the meetup. I mean, maybe all of you already know, but just in case someone comes, with a partner or something, if you go to this link, you will be able to join a meetup that we do. I mean, we are not very regular, but maybe we've done like 2 or 3 meetups the last year. So you will be able to be notified if we do more of them. And here you have the Wi-Fi. I will give you 1 minute. Is anyone interested in the Wi-Fi? No? Okay. So we can skip.
Oops, sorry.
So we also have a Twitter handle that you can follow. It's at Scala Bcn. And yeah, we also have a mailing list. And this is the same link that was before. And if you go to the next one, yeah, basically what we do is a combination of talks, social events. Sometimes we go to just take a beer. It's not always like just presentations. Sometimes we do also small exercises to practice, like we do pair programming and stuff. So it's a little bit of a mix of things. It's not always the same. And yeah, one thing I want to say is we are not like perfectionists or elitist people. So everyone is welcome to offer any talk or any activity. And if anyone is interested, feel free to contact me or anyone, that's here. And yeah, just you are able to do almost everything here that's related to Scala. So if you want to be where Guillem is, or organize something that's fun, feel free to suggest, please. Perfect. And with this, I give you Guillem.
All right, so let me get where I was. Okay, welcome to this talk, ABC of Scala.js. This talk aims you to introduce you to Scala.js, show you how you can get started with it, and we also see some of the tools available in the platform. In the net, you can find many documentation such as tutorials, blogs, resources, also speeches from the people who created it, and so you can know the philosophy they had in mind when they were developing it. This talk is going to be focused on the perspective of the user of Scala.js, as in, okay, I'm a Scala developer, I acknowledge that Scala.js exists. What can I do with it? Or how should I start? Or should I even start with it? Maybe it's not for me. But there's really a lot to cover, so let's get ourselves started. Then me. My name is Guillem Iscla. I have 8 years experience in several countries in Scala. And just very briefly, I'm in Scala for the functional stack. I've also done some big data. And I deploy my things in Kubernetes, among other things, of course, I do with Scala. But I'm not the star of the day. The star of the day is Scala.js. And what is Scala.js? When I was a junior, I heard about this project, and I had very weird thoughts, like, okay, Scala is a language. I know about it. JavaScript is a language. And I know they don't resemble each other. So what are these guys doing? It's creating a language hybrid of somehow. Actually, it's very easy to understand if you think in the right parameters. So you have the Scala classic, so to say, the Scala we use every day. And we all know that when we build Scala, we come with a jar file. And that's very good news for us. With a jar file, we not only have all the advantages of the JVM, we also can integrate any Java library that we may like. So the Java community is huge. So if there's some functionality you want, you can integrate there. So that's it's always very convenient for us. So, but thinking in these schemas, Scala.js could be like building and getting a JavaScript file. And that's not really new. I mean, that's what TypeScript does. TypeScript is a language designed to improve JavaScript, because JavaScript is very powerful, but actually lets you do too many things. And you end up having weird problems at runtime. And TypeScript is preventing this by its strong type system. That's a good fit for it. But Scala is as well strongly typed. So I guess some people thought, OK, what if Scala can build into JavaScript as well? And here we go. Just for the sake of completeness, there also exists Scala native, which is something that builds into something close to the assembly code of the machine, I understand. I have not done anything with it myself with Scala native. If someone has, please make a talk with me, because I'll be here in the first row eating popcorn. Looks so interesting. So I say it builds. Actually, it builds with different, of course, SVT commands. So Scala Classic, we build it with publish, if you're working with a library, or assembly, if you want to, well, assemble the code and all the libraries you're using in your project, and you have an executable a jar file that you can execute. In Scala.js is fast-stop.js. I think this word name came because it used to be fast-link.js. There was to be some of them, but they got deprecated anyway. The documentation just tells you to use this one. That's what we will do. And I look it up how you do things in Scala native. I believe it's native link. So that's it. Then why Scala.js? Why at some point, personally, I thought it would be a good idea to invest time on learning this. Well, I wanted to build web apps, and I didn't really like Play's Scalatra. That's one option that was there. I mean, I found it not scalable. I found it very difficult to build big things. The connections were not really clear when I was writing code. So I thought, well, maybe I should go with TypeScript, but I have to learn a whole new language to do this, that I want to do. I mean, maybe there's an easier way. And, well, Scala.js apparently just having your Scala code and building in a different way. Well, that looks easier for me, at least that was my case. At the end of the day, though, after learning Scala.js, I ended up thinking, okay, but I'm still missing this. I ended up learning TypeScript with React in my case, because really, if you have a project with Scala.js and you want to share and make other people collaborate with it, it's not so easy. So I guess I thought it was limiting myself if I was only learning that. But I don't consider that my time in Scala.js was lost at all. I mean, I had to learn some more SVT to understand what was going on for me to build my projects. And I also polished my architecture skills. What do I mean with that? I mean, of course, when I develop on the server, I do factories, I do repositories, I do services, I do all this kind of stuff. But I also know, I've done it so many times that I also know what I'm gonna implement there. I also had in mind the code. But when I was developing web apps, I was like, okay, so what's this? Is it a service? Is this an application? I had to revise the concepts a bit on its own. Okay, so we have the who, we have the what, we have the why. We're missing just the where. You can go, if you want to know more about Scala.js, there's the website. You'll find tutorials, blogs, resources, everything you need and more to get started. And the when and how much are up to you. So you guys decide how you're going to invest your time. OK, so this is Scala conference, and I want to see some Scala code. So let's see some code. Let's see how you get started. So this is just a project that you have when you start IntelliJ, say new project. I put this version 2.13. And if you want to compile with Scala.js, the first thing you need to do is you need to add the plugin. To add the plugin, you go to the projects folder here, and you create a new file with extension .svt. Anything with extension .svt, you can put the plugins here. But everyone ends up using this one, plugins.svt. And here I will add the plugin. So I don't want to mistake the version or anything, so I'll move to my cheat sheet. OK, so here I have. OK, so we need to do something more.
Guillem,
Sí.
can you do presentation mode So it's easier to read, please.
Can you call me out? View?
View.
Presentation.
Thank you.
All right. Okay, I'll change files, but so far I can do this one. And then I added the plugin, but I also need to enable the plugin. And then all this is in the documentation of Scala.js, your first program, that apparently you need to specify the main class that you're going to use. Somehow it doesn't figure out on its own, like this. So this will be my class path. And then there's this flag you also need to use. Yes, use main model initializer. And you have to set that to true. Don't ask me, that's just what the documentation says. It's not a big of a deal. All right, so, yeah, I'm sorry, I'll have to exit here. I'll put some zoom if I can. Can I put some zoom? No, well, then I will create the class, so it's here. First I will add the package. And finally the class. Here. Okay, so this is Scala class. You also need for it to be a main method. Scala will do it like this. This is already just a Scala code. And we've already done quite a lot, so I'm just going to print something. All right. Okay, so we have a project here, and we want to see what it translates. So I'll go to my SVT console, make sure that it has all the changes. And then I type the command for compiling Scala.js, which is fast.js. Right, so we compiled. So apparently it's in this folder, Scala.js ABC, target, Scala 2.13. Okay, let's see it. So set it to the project. Yeah, so here it is. So it's this one, Scala.js ABC fast.js. We also have this one, .js.map. So what is this other one? Yeah, this other one is something to web development. I understand that the browser may ask for it, and then the browser has understanding of what the functions are, and it helps you debugging as a developer. Okay, so these are the files that I need, right? So let me copy them in somewhere where I have an index.html file. Okay, Scala. Both of them here. And I want to show you about this HTML file now. So it's this index. Let's see it. You can see that this index really has nothing. Just in the body, just really specifies the source for this same file. Okay? So let's see it in Google. So here's our web page. Yeah, but there's nothing. I put the print. Yes, I put the print. When you put the print, translate to console, console.log. So I actually expect it to see here. And here's my print. So we're already Scala.js developers. We developed some code in Scala, and the code compiles to some JavaScript file that does what is expected. It doesn't do much, right? I mean, web developing is not about going to the console and see prints. So we want to add DOM objects, XML DOM objects, such as div, such as piece, such as button, all these objects. we need to add them through a library. Okay, here. So this is the library. Okay, maybe it works here on presentation mode a bit. So while IntelliJ is catching up, so here's the library that I'm importing. Anyone has ever seen these 3 percentages here? Yeah? If you're not familiar, I just will explain a little bit about it. So if you have, you surely have seen some imports that you have with 1 percentage here, and some import that you have with 2 of them. So what's this about? So when you publish a library in Scala, you want to publish against its major version. So for example, you want to maintain it with 2.13, 2.12, or Scala 3 if you have. And to do that, you basically do this pattern, underscore 2.13 in my case. Yes, but the 2 percentages, what it gives you is it adds this underscore 2.13 in my case because that's the version of the project. Okay, so that's how the 2 percentages work. What about the third one? So third one, we'll figure out by seeing what we have. Maybe it's a little small, but it's here. I'll read that for you if you cannot read it. It's 2.13 here, as in the other one. And then we also have SGS1, which is the first version of Scala.js. We added the plugin 1. There's also the 0 one. And meaning that, all this to say that these 3 percentages will import either the JavaScript version of the library, if we are in a Scala.js project, or it will import the JVM version of the library, if we are in a non-JS project, right? Okay, so let's see a little bit about it. So already I had the screen. I will keep it. And this will be familiar to you if you don't have any JavaScript code. So to add any DOM object, the first thing you do is you do document create element. So I'm going to create a div object. And I want my div to have something, not just plain div. So I will set the attribute, class, and then container fluid. So these are the things, these are the tags that go against in your CSS. If you have a CSS telling you, and you want to specify how you display the div that contains this tag, is in the CSS. This is what goes against it. And next thing is, yeah, well, of course, I want this div to, I mean, this tag you don't see it, so I want something I can see. Yeah. Yeah, sorry about it. I'm just moving along. Okay. Okay, so that's really all I want. I'm done. No, I'm not done. You have to remember that HTML is highly nested, and I created the div, but it's nowhere. So I need to nest it into the tree. If not, I won't see anything. Okay, now I'm done. Okay, so let's see that again. So just the same as before. Reload to update the specific changes. Fast.js. And I go here. I copy the new files, and I open Chrome again, and then I see it. And then I see it. It's my div here. My div here that contains that is exactly as I put it. All right. So since we can do web pages, so this is our hello world. But the nasty thing you've seen me doing was, okay, you see me, I can create JavaScript files, right? But I was moving them with a copy command, and this is not really how we want to build things. We want to have a more secure pipeline. So FCT has to come to the rescue. And we'll use something close to multi-project. Everyone familiar with multi-projects? Yeah, I mean, multi-project is a very convenient tool, right? You can have, you can plan to deploy 2 servers with a lot of share code, and you don't need to provide the share code through a library or copy pasting. The share code can be in the same project, and then the 2 JVMs can depend on that. I mean, there's many patterns on the multi-project. It's a very versatile concept. In this one, we'll use a cross project, which is a kind of multi-project. It's just the things that they built on, they are not all the same type. They're not all JVM. So we'll do that. And well, building things, I mean, it's not that it's a brainiac, but it takes quite several things. So I've done everything beforehand. I've organized a little bit the build. Not everything is in the SBT like line by line. I've added the cross-project plugin. And in the cross-project plugin, you also need to define how you want this cross-project to be. You need to specify the SBT parameters. We also want to create a server, to create a Scala code that's compiling into a jar server. And the index.html that I created, it's going to be now in the resources. So all this is done. We have this building plan. And I've left this, I'll show you a little bit of SBT magic on how you can do some automation here. So I won't go to everywhere. It's just a big plan. You have to believe me, it's all part of the plan. Okay, so let's see how this works out for our friend Mastermind Psychopath. Okay, first here. Okay. So the project is changed. When SBT is catching up, I'll show you. So first thing it happens here. I've added the cross-project plugin here, and also the native packager to build up things. If anyone is wondering, well, you're talking about jars, but I deploy my things in Docker. It's the same thing. We'll make some changes in SBT, and the way SBT works is you do some changes on the bottom, and it on the top picks all that. So the changes we'll do will apply both to the jar and the Docker. Then another thing is here in the SBT. You see that now we have the 2 projects. The front end is here, and the back end is here. So there are 2 different projects here, and with their own folders. And there's also this shared folder here. This shared folder is the cross project. In the shared folder, we have the shared.js, which is going to be the mother of all the web apps that we will have in this project. If you want to build several web apps and they share some code, you just put the code here, and it will spread among them. Same with the JVM. If you want to deploy several servers that share some code, you can put the share code here, and the JVM will have access to this code when it builds or when it runs. And there's a shared folder inside the share one. I was a little bit puzzled when I saw that. What does it mean? Well, we're talking about, sometimes we do jar files, sometimes we do JavaScript. But before all that, everything is Scala code. So if you put some Scala code here, this Scala code will be shared among the shared JVM, shared.js, so it will be shared among all the projects we have. So this is the configuration that we have for this shared one. And just want to point it out that we'll use Circe. That's not going to be now. But Circe has also these 3 ones, which means that whenever we are in a JVM project, we'll pick the Circe version of the library for the JVM, and whenever we are in a Scala.js project, it will be the Scala.js version of the library. All right, so what do we want to do? All right, so well, this all works, but we still have a little bit of a problem here. So when we build the front end, we'll create the JavaScript files in this folder, and they won't be in the resources of the backend. I mean, what we really want is these JavaScript files to be resources of the backend. Resources as in something in the resources folder here. So in the resources folder, I have the index.html as
Sorry, I have one question about
Sure.
About what you said with the shared.
Yes.
The shared.
Yes.
Like, what's different? Like, what's different between putting something on the shared JS and shared?
If you put something in the shared.js, it can be shared among all the Scala.js projects, but not on the JVM projects. And if you put something in the shared, the Scala JVM projects can also access it. Well, we actually will do that afterwards. Maybe it's clear. It's more clearer then. I mean, when I saw examples, that it was like, why so many folders? Maybe I don't need all of them. Okay, just here in the resources, I have this public folder. This actually is quite important. In this public folder, it will be everything I want to share with everyone who accesses the API. There's the index.html file, the CSS files will also go here, images that I want to have in the deploy, and as well the JavaScript files. So I actually want the JavaScript files inside here. And then I did some SBT. I did a lot more SBT. I mean, it was a little bit difficult to come out with things. Sure.
When you say that the JavaScript files are going to go to the public folder, is because the front-end project will be compiled, and then they will be placed into the public folder after they are built?
Yes. My aim is to run the backend, and running the backend will trigger as well the compiling of the front end. But not only the compiling, but also building of the front end, and then the output of this, I want it to be on the backend specifically there.
Okay. So let's say that the front end is going to be packaged inside the public folder of the backend. So it will be packaged inside the backend.
Yes.
Okay.
Yes. You could, I think it's accurately like you say. So I came up with this piece of code, the SBT code, using the package mappings. The package mappings are the files that are relevant to the building of the front end. So all the files that the SBT will need will be in this package bin mappings. And then here I'm adding the output of this instruction. When you do .value in SBT, well, I mean, SBT is quite complicated. We won't go through every detail how SBT does things. But .value means that this will be executed if it needs to be, if there's any change inside. Yeah, this line is a little bit tricky. Don't worry too much about this. It's just because you remember that there was the .gs and the .gs.map, so that you have two files. We'll like both to be there. And then if you go to the type of the mappings, is a sequence of a pair. The first element of the pair is a file. The second element of the pair is a string. That's why in this .map, instead of you start with a file, but then we also add the string here. So I got this, and then so you need to run out the changes. If not, the SBT console is going to be, yeah, just have what you had before. And then I want to see the mappings here, just for you to understand more. Backend. Right here. So these are all the files relevant to the build. For example, we have the application configuration. We also have the index.xml because it was in the resources. We have all the class files that the front end has. And as you can see, the backend is because, well, it's the backend, right? But we also have something that actually comes from the front end folder. And it's actually the GS file that we wanted. So that's really cool. But I had a problem when I was doing that, because I could see that I already could access the files from the backend. I could deliver them through my endpoint. But it was precisely as it was outside the public folder. And this was kind of a little problem. I mean, I want to design my code, so I just want to share the public folder. Let me show you the endpoint. So this is the backend code. So this is the endpoint where we'll access and we'll have the index HTML. But these assets, it's going to deliver everything that's in the public folder. Just we change assets by public and we have the file. I mean, of course I could do a workaround there, but it didn't feel safe. But actually, I was discovering the power of the package mappings. And really all you need to do is this. No, not this one. All right, so. Here. Okay. You can specify precisely the path that it will be in the package bin mapping. So by just doing this, this changed, and now it's going to be referenced in the folder. So the output of the front end is going to be in precisely what I wanted. So I can try this one. So alrighty, so we started the server. Close this one. And here we have, well, it's the same code before, but notice that now we are getting the JavaScript from this folder, from this endpoint instead. And if we go to this endpoint, rather than Scala.js rocks, okay. What we have is the JavaScript file that, of course, needs to be available. If you see the JavaScript file, you see, well, it's very long, and you just do one print. There's a bit of overhead, I understand, with the small programs, but it gets better. Okay, so we have, yeah. So we can build, and we can build in a nice way. I mean, now every time I'm going to start the server, it's going to recompile everything if anything has changed. I mean, this really helps a lot. And we'll see some concepts of Scala.js now. First one being facades. Facades are kind of the libraries of Scala.js. So, of course, you want to integrate with some JavaScript libraries that are out there, but you're writing Scala code, you're not writing JavaScript code. You actually need a facade that's the one connecting the Scala code to the JavaScript code. For example, this is a screenshot of the facade I was using to build the DOM objects. When I type document, it was portraying this document here. You can also notice that here the guy is, well, using this compiler tags and so, but it's typing JS native, and it's returning different types all over. Well, actually what it means here is the JS native means, okay, so you're going to go to JavaScript and execute this instruction, and you're going to return something that I guarantee that it's going to be this type. It's the author of the facade is the one making sure that the type is correct. I mean, the Scala code just believes that it got correct. That's the responsibility of you building the facade. Then another concept, future is now. Well, that's a little complicated, but I really thought this was a complicated concept. I mean, what I mean is there's no future. Everything is in the same time. As being more specific, in Scala we have futures, and everyone knows what's future. Well, you type future, you type some code inside the future, and that means you're going to create a thread, and this thread is going to be executed, and you can access the result, the computation, through the future API. It's a monad, and then you work with a thread this way. And Scala.js also have futures. Not only also has, it's the same class. The same class you use in the JVM, it used in the JS. Well, that's great, but surprise, surprise, in JavaScript, there's no threads. It's just one thread. actually looks like this. It has this event loop. You have a stack of all the functions that they're being called in the JavaScript. So it spends some time computing this. Then it spends some time looking on the handlers. So if you move the mouse or you click somewhere, there are some handlers that might be triggered and might put some more functions or do some things. And everything is empowered with JavaScript APIs that the browser provides. So Chrome, Opera, or Firefox would provide resources for this to resolve. And that's very nice, but we just have one of it. So how come the behavior is so different from the JVM and the JS? Well, the trick is they use a different execution context. When you create a feature, if you want to do .map on it or something like that, you need the execution context to import it as an implicit if it doesn't work. But you do a different one with Scala.js. So this screenshot, I think, is a little bit small, but maybe you can read. This execution context of the JS submits into the JavaScript runtime task queue. So it submits here. So any function that you will have in this feature will pile up here. And that's how it works. OK. And now is the big deal.
Sorry, do you have an example of code of that executing a feature or something in the project?
We'll do a feature in Scala.js, yes. Yes.
So it's basically the same, no, in Scala?
Yes, that's the whole beauty of it. I mean, you have to learn some building, but when it comes to code, it's Scala code again. So if you know how to code Scala, you suddenly know the language you're using for the web apps, yes.
Right, so you still use features, it's just that they are not very useful.
Features not useful, sorry?
So you still use features, right?
Well, I mean, some libraries use features. I mean, you mean that it's not Zio or something like that?
No, I mean, if it makes sense to use features, or you just do everything synchronously.
No, of course, no. Well, when you download something from a website, or when you ask the server from the JavaScript, I mean, that's a feature. You have to model that as an expensive computation. So yes, features is still a thing in Scala.js.
Do you know if these features, when you are programming in Scala.js, are translated to promises or something like that in JavaScript?
There's promises as well, but they're features. I mean, in Scala.js you will find some promises in somewhere, but you can do this promise.feature. Yes. So now is the big deal. Now is the big price for using Scala.js. So let me explain to you what's happening in this slide. So this brave guy's name is Jason. It's a Greek hero. In Catalan, for example, is Jason. In Spanish is Cazón, but in English is Jason. And he is a hero from the Greek mythology, and the thing with them is they like to do deeds. And Jason was very into something called the Golden Fleece, which is a magic item brought from the gods, and he went to the end of the world to pick it, and this was a big thing. So we want to represent this deed into some famous notation. So we'll pick JavaScript object notation, also named JSON. And we all know what we need to do when we want to translate something JSON, right? We all know the drill. You have to gather all your documentation. You go to a meeting room. Frontend has to gather all the documentation, go to the same room, and you have to agree what schema you will use. If the frontend sends you a schema that makes total sense for them, and it's so beautiful, but you don't know it, you will not be able to read the information they send you. The same way the other way around. If the response that you send is a JSON that it's so beautiful, but they don't know the structure of it, the code cannot read it. So you have to read it first. Until now, because in Scala.js, there's the same code base. So the same file, it's going to be the file that contains the data that's translated from JSON. The same file. It's not a copy of the file or anything. The same source file is going to be used from the front end and from the back end to model the data. Not only that, but also the code that goes from JSON to this class. It's going to be the same code, the same files that had the Scala code, going to be the same for the front end and from the back end. So, I mean, I think that's very powerful. And, well, I mean, that's, let's see if JSON can fight this way back and bring us some magic. All right. Well, stop here. Okay. Sorry, not so used to presentation mode, so I have to be switching here. Yes, because I added technical here. So
maybe you can just make the font bigger and you don't need to enter the presentation mode.
yeah, you know why?
Try to control and scroll the mouse.
Control and scroll. Yeah, this doesn't work. Control and plus didn't work either. I tried a couple of things.
So you know the action shortcut? You can type any action.
No, I don't know the action shortcut. Sorry.
There's a special shortcut, then you can type anything you want and just hit me.
Control Shift A, maybe?
Control Shift
Or Shift
A.
Shift, try Shift Shift.
You can increase font.
Control Shift A, I think it's gonna work. Okay, actions, like here you type font or something like that.
It's together.
Font size.
Okay, font.
This is a very useful shortcut. by the way.
Font. Change the font. Okay, yeah,
No.
this is the one. All right. Yeah,
Okay.
so we got it. Thank you so much. Okay, so now we're going, Gerard, to the share folder inside the share folder because something appeared here. So this is a user. User, it's going to be the class that's going to contain the data, which has 2 strings and an int. But you can go crazy on it. You can do anything you like here. And here are the codecs that are going to compile it's going to translate the JSON. So this is Circe code. I mean, if you are interested in Circe, I mean, I thought that was very interesting. I proposed some conference on Circe instead of this one. This derived codec, it just means, so to say, okay, translate the class, the user class, in the simplest way you want. So if the first thing that comes to your mind when you want to translate this into JSON. Of course, you can make a more elaborate code and you write it here. And this will work from both the front end and the back end. So we'll see that because on the back end, we have now a new endpoint, get user, and this will return a user. But the backend doesn't know about this user, so we need to do many things. Well, not many things. We just need to import the user. Okay, so we import the user, and then it's happy. But what's this user we imported? This user is the same user that is in the shared share folder. It's the same thing. The backend has access to this shared share folder in terms of importing. But we are also using this as JSON, which is a function that transforms this user in JSON. And it needs to know how. It needs to know what kind of JSON you're going to use. So you just need to import the implicit. But it's the same again. So imported this implicit, and then it's happened, then everything compiles. Okay, so that's the front end. Let's see the sorry, that's the back end. Let's see the front end. So what the front end does now is it gets the user, and this actually is a promise, and we transform it into a future. That's what you're portraying. This is a for comprehension of basic and futures. 100% Scala code. There's nothing else here. That's the beauty of it. And in the yield, we want to decode the text we had into a user class, but we don't know what user class is. So we're front end. So how we do it? Well, we do the same way as the backend. Nox mix user. So having that is happy. Now, okay, I know what user is. Great. But this decode also translates from JSON to our class. How can we read the JSON? Again, we just need to import the implicit that we have access. And now it's happy. And now we can do the thing. So let's see if really everything works. I'm going to run backend run, but this is going to compile the front end, put the front end there, compile the backend, and run the backend. That's how SVT works. You do things on the lower level, and everything picks up. Oh, it's getting better now. Maybe we'll have to speed up a bit. So first, we'll see this This get user is the endpoint, and yeah, it really retrieves the user. But if we go to Scala.js rocks and we see the console, yeah, okay, this is, I knew this was going to happen. When you do web development, you always need to remember to clear your data, because when I was speaking the old JS, it was like, yeah, you want this JS, I have this JS in my cache. No, you have to clear the data, because if not, it's picking the one I used a moment ago. Now it's picking the new one, and it's printing this. I got a user, and it's his name, John Doe, and 24 years old. So if you go here, it's actually using the user as a case class, because it's a case class. You do the name on a case class, and you have it. So again, all the same, we're compiling different things, but we're using Scala code. That's cool. But really, this doesn't look like a very elaborated web app, right? Let's see if we can ever make an elaborated one. Okay, so just I changed some code. I added here. Clear data. And now it looks better. Now it has a web app, it has some new look, it has more things, and it has a button. You can click the button and something happens. Let's see how this was achieved. Well, this was achieved by having a front end that's bigger. Inside the front end, now it's not just adding one div, it's like doing more stuff. It's like doing much more things. For example, this button, when on click, it displays this. But maybe you want to do something more elaborated. Again, the front end is now bigger, so the function that we used to have to pick the get user and so, now it's in a service, and we can use that other places. Okay. So, use of service, get user. Now, I think you guys are asking about this as well. Get user returns a future. I mean, stop thinking about we're in JavaScript. This is a Scala future. So I know how to use a future. I mean, there's, for example, the for each method, and then the whatever result that's going to be the message that comes from the server. I want to add it into here, and I'm just using the Scala code to fill out something. Again, no, I don't need this. Okay, back here. And then get user actually goes to the endpoint, picks the information, parses information, does everything well done. All right, so we can do actually realistic web apps. I mean, of course, this is bigger, but it's not as big as you may want for a big web app, but you can get bigger. Now you can have a project. Yes?
All these HTML elements that you saw in the Scala code, everything is typed. I mean, for example, the on-click method that you were assigning this function for getting this behavior is typed with all that you need to reside.
I think I was about to answer this question because the next thing I'm going to do is like, what's wrong with it? What's wrong with this is like, okay, this is the code you were portraying, and this code is not readable. I think, well, you agree with us. This is like you're adding things on top of things. This is because I was starting here, and I added this thing, for example, this attach new element, which helps a bit. It does some of the work, but when you develop HTML, you want to see the HTML there. You want to have the feeling of it. You want to see the HTML tree. So actually, you want some big idea where we would like to pick is GSX. What's GSX? GSX is kind of a syntax that the React framework has. It looks like this. So you have pieces of HTML here, and you kind of assign this to a variable. And then this is very useful because you can reuse them. You can merge parts of HTML with others, and you have a really sense of how the XML looks like, among other things that React has, but this is GSX. So it would be so nice if Scala.js has something like that. Well, actually it has. This guy here is creating a facade for Scala.js. and apparently you can use React with that. And the code that I just showed you here, that it's kind of, well, it's readable at some point, but you don't get the sense of the HTML. I translated into Scala.js React, and this is how it could look like. Sorry. And if you go to the HTML here in the Google Chrome, you see that it's precisely that readers has. It has a top, it has a welcome, then you unfold this. And it's the same structure that you'll have here. Right? Yeah. So you can read the HTML from here. Actually, so this is how the coding kind of ends, because I was adding this one, my experience on preparing this presentation. And this compiled, and I could build the thing, and then I was running it. And the browser said, yeah, we're missing the React. It means that I had the facade, but you also need to import the JavaScript that does the work, not just the Scala code that's correct or not. And then I was trying to add the React, but then I found some broken links, and then something that was like, maybe I'm not in the official page or something like that. It just, well, that's what you actually face when it's Scala.js. The community is not so big, and things are not so strongly maintained. So I thought, maybe that's not how everyone does this. I mean, maybe people just start with this code and then do something better that's actually more readable without using React. I think that React is more of a choice that you do. Actually, one big advantage of React is that it lets you compile TypeScript. It's very difficult to compile TypeScript on its own. But Scala.js, it compiles the code. I mean, yeah, that's what it does. So it's more of a choice if you can go to Scala.js React. So I think it's good that I show it, but broken links and so how people does it, I couldn't really tell. Okay, so that's a little bit of how I did with the Scala.js. So what do we do with that now? So I have this guy who is very eager to make a point. So if you want to read this point with me, you will never find another Scala.js developer. Yes, it's very difficult already to find us Scala developers. If you let's say that Gerard likes Scala.js so much that he will spend all the weekend coding Scala.js and will go to the companies and I will make this web app that we always wanted to make. Next week he finds another job. So what does the company do with that? Who maintains that? Who understands Scala.js? Yeah, that's the thing. You have maybe the core tech stack is not the first thing in mind when you go to Scala.js. At least I wouldn't recommend it, or I would have second thoughts. And so what should we do? Maybe we should forget about the last 50 minutes. I don't think so. I mean, it can mean other things. Maybe you have a friend from the front end that says, okay, you do Scala, I do front end, but Scala looks so cool, and so, I mean, what's this about functional programming and so? Maybe you can do pair programming with him, and you can get running the Scala.js React project that they couldn't. And then you learn about React, because React is not only about JSX, it has also the React hooks and the React classes, which has nothing to do with Java classes, so to say. And then you can learn together, and it's a good exercise. Another thing is, I said that the core tech stack might not be the best place to put your Scala.js code, but if you have some spare time between sprints and so, and you have this consultant that always go to the endpoints to pick some information and says, it could be so nice to have a web app just for me, not for the customer. Maybe you can make an experiment for them and you learn about SVT. The consultant has his life easier, so it's productive for the company. And if this ever gets deprecated or not maintained, that's not the end of the world. Consultant goes back to the endpoints. As long as there's no a lot of impact, if it gets unmaintained, you can try that. And it's probably easier than learning TypeScript if you already know Scala. And this was actually my case. I mean, I was I want to build web apps, but I don't want to spend my whole life. So I did some baby step, and I refreshed my JavaScript skills with Scala, and I was building code, and I was getting myself used on how the web architecture looks for me. And then at the end, well, okay, no, just maybe you actually have to learn more about it. Or maybe you can create a library there. I mean, I find it myself very challenging to create a library in Scala, in normal Scala, because what I'm going to do that no one, someone else has not been done, or how I'm going to do better. But if you want to, if you're thinking what you can do in Scala.js, I mean, the ideas are non-stop. Actually, the first thing that showed me that I need to move away from Scala.js because I was missing a facade from a JavaScript library that I wanted to use. So if you create a facade, you can publish it there, you get feedback, you get credit from it. It's like, okay, I'm someone who creates libraries and people use. So, I mean, you have many options, or you can imagine more. I don't think it's really time waste. But that's everything I wanted to share with you. If you have any questions, I'll be happy to answer. Yeah?
I have a question.
Sure.
How do you test it? You run the typical Scala test or Munich test for the Scala part, and then the generate code in JavaScript with all the JavaScript testing frameworks? Or?
There's the unit test library for Scala.js that helps you, and you can do some unit tests with that. Integration tests, I'm not sure, but also depends on how you plan to do it.
And one more question. When you code in Scala.js, do you usually follow the typical patterns in functional programming or Scala, like immutability and this kind of stuff? Or different approach?
No, it's the same. Of course, in Scala you can also mess a bit and not use these patterns, but in Scala.js it's just a Scala code. Maybe the only difference you may find is when you type the code that reflects to HTML. I don't know how Scala.js React Facade does it, but at the end of the day, you just combine with HTML, so I'm sure that there you could find as well some place to make it functional, so immutable, and all these principles that we like. But the rest is just a Scala code. I mean, that was the main point of the conference. I'm explaining a lot of things, but when it comes to coding, you don't have to think anything else. It's just the future is the same future. You can have options, you can have all the monads you need. The JSON is actually the same code for both, so you work in Scala code besides when it comes to building.
One question. Do you know, or maybe it's in the website, do you know anyone using this in production? So I guess it's people actually using it seriously.
No. The question is, do I know anyone who uses Scala.js in production? No, I don't know anyone. As I said, I mean, among all the Scala developers I know, few of them even know what's Scala.js. So, I mean, I don't think it should be in production. Even the web development is a very challenging environment for the competition, meaning that because it's not like the server. When you develop a server, you know which machine is going to run. It's going to be one machine. It's going to be the machine of your choice. It's going to have these specs. But when you're creating a web app, the web app will run in millions of devices of the users. And you want the web app to be always updated, and to be always working. That's why you want to keep. There's a lot of trend on keeping the standards, and everybody just choosing the framework that helps you, but most of all that compiles into everything and has no problems that you cannot foresee. That's why investing on Scala.js on production, I would think once, twice. It's like I think it's a very cool thing. I just don't want to imagine all the problems you may have if you do that. Okay, if you have any more questions, I mean, I'll be here a while. But thank you for coming here and listening to the talk.